You need the limit from the left to equal the limit from the right to equal the value of the function at that point. That's what you need to be continuous. Remember, there are three things to be continuous. F of a has to be defined, the limit as x approaches a has to be defined, and that limit has to equal f of a. So, yeah, f of a 2 is defined, the limit for both sides is equal to 0, and 0 is the value of that function there. All right, so just discontinuous at 0. Am I continuous from the right or the left at 0? Or neither? I'm continuous from the left. What does it mean to be continuous from the left? Just from the left side. That's exactly right. You take all of those three rules to be continuous apply when you're taking limits from the left. So f of a has to be defined, the limit from the left has to exist, and the limit from the left has to equal f of a. All right, so that was number 2.
Can you do number 7?
I do number 7. Sure. So find the first and second derivatives. But one thing I would highly suggest you do on the exam, and this will help you, is at the very start of the test, before you work any of the problems, maybe flip the exam over to the back and make yourself a little f of x, f prime of x table. That way, if you end up really sitting there for 3 hours, after 3 hours, if your brain is mush, you at least have something to refer back to if you're trying to take a derivative or if you're trying to take an antiderivative. Okay? You get 3 hours. Most people don't take 3 hours, but if you want it, you got it. Okay. So I would highly recommend you do that just at the very beginning so you don't forget. Okay, so number 7. So I've got y equals cotangent of 8x plus cosecant of 2x. All right, so the first derivative. How am I going to do it? I can use u. I can do it in my head just as easily.
Just think of the product.
It's not a product rule because I don't have the cotangent times 8x. I have the cotangent of 8x.
Can you pull out
It's a chain rule. Okay, this is a chain rule problem. Instead of the cotangent of x, I have the cotangent of a bunch of stuff. So what is the derivative of the cotangent of a bunch of stuff?
Secant. Swipe down. Negative.
Negative cosecant squared of all that stuff times the derivative of my stuff. It is 8. So that's the first part. Plus, now I want to do the second.
negative
Cosecant 2x cotangent 2x times 2.
Can we leave it like that on the file, or are we going to have to?
You can, but then it says to find the second derivative, so it might be to our benefit if we simplify.
Okay.
Okay? So for this one, let's rewrite it as negative 8 cosecant squared of 8x minus 2 cosecant 2x cotangent 2x. All right. Okay, so now let's take a look at the second derivative. Start with the first term.
Okay.
Negative 8 cosecant squared of 8x. How would you take the derivative of that?
Is it negative 8 cotangent?
Or let's think of it first as negative 8 times the cosecant of 8x squared. Does that make
This
sense?
is negative 16.
So negative 16 times cosecant of 8x to the first power now
Now take the ones.
times, now what's the derivative of the cosecant of 8x? Negative cosecant 8x, cotangent of 8x times 8. All right, that's that first term. Now what about the second term here? Minus. How am I going to take the derivative of cosecant 2x, cotangent 2x?
It's a product rule.
It is a product rule problem. I've got two things multiplied together. So what is the product rule?
Oh, the first derivative
the first times the second plus the first times the derivative of the second.
So it's also going to be a chain rule problem as well because we have to.
And it's also a chain rule because I've got 2x there, not the x. Okay, so let's do it this way. I'm going to write it as minus 2 times, and now we'll just worry about the product rule. So we'll call this the first and that the second. So the derivative of the first term is how much?
I think when I say cotangent, is it?
No.
Negative tangent squared.
Cosecant.
Negative cosecant of 2x
Times cotangent.
times cotangent of 2x
2.
times 2. That's the derivative of the first.
Which one's the derivative? I don't see it.
This whole thing is derivative cosecant is cosecant cotangent. Okay? That's the derivative of the first times the second, cotangent of 2x, plus the first, cosecant of 2x, times the derivative of the second. How do I take the derivative of the cotangent of 2x? Negative cosecant squared of 2x times 2. Very good. And there you have it. And you can leave it like that on the test.
On our exam, when if I was working the integral, I guess could you say when you do like how cosecant is squared? Could you pull out the square and say, well, I'm saying this whole thing is squared, and do like the derivative like that? Or no? Like just like how you did right there, where it's like negative cosecant squared with 8x, and then.
If you were integrating this part of it right here,
Yes.
you would first let u equal 8x.
Okay.
Right. Then after that, you got the negative cosecant squared of u. The antiderivative of cosecant squared is cotangent, and you're done.
So what are the other ones where like is it D? I can't think of what they were. Where you have to do then like dx at the end.
Implicit differentiation.
Like a related rates problem?
No, what he said.
Implicit
Implicit
differentiation.
differentiation. Okay, let's do an implicit differentiation problem. Eventually, I'll get to your optimization, I promise. All right.
No more time. We only have 11 minutes.
So let's say I have x squared sine of 4y minus x cubed y to the 4th equals 9. And I want to find the derivative dy dx. How do you do this?
Find the derivative
You
first.
just take the derivative. So notice I've got a product. I've got this times that. So the derivative is going to be 2x sine of 4y, the derivative of the first times the second, plus the first times the derivative of the second. What's the derivative of the sine of 4y?
Cosine
Cosine of 4y
4.
times 4. But because this was a y and not an x, I also multiplied by dy dx. Remember that little rule when we did implicit differentiation? Okay. Because y is a function of x, when you take the derivative, it's really a chain rule problem. So you also have to multiply by its derivative. Minus, then how do you do the next term?
3x squared
3x squared y to the 4th
plus minus
minus
x to the 3rd
x to the 3rd
4y to the 3rd dy
times 4y to the 3rd dy dx. And that equals 0. And then what do?
You put everything on one
You
side.
move all of your dy dx's on one side and everything else to the other. Okay. So I'll leave it this way. 4x squared cosine of 4y dy dx minus 4x cubed y cubed dy dx is equal to 3x squared y to the 4th minus 2x sine of 4y